So 7.1 is solving differential equations. Let's just talk about what a differential equation is first. So differential equation is an equation that has a derivative in it. So in this course, we're only going to work with a certain type. And the type of equations we're going to solve, you can always solve by separating the variables. And then we can find a general solution. If it's a general solution, it'll be like a family of functions, a family of curves. It'll have a plus c, or a particular solution. But to do that, they'll have to give us an initial condition. Let's look at the steps we follow when we solve a differential equation. So, right, we're starting, if it's written as y primed, we want to write it as dy dx. The next thing we're going to do is try to get all the x's on one side with the dx and all the y's on the other side with the dy. And then part of that's going to be separating the variables. The other part's going to be multiplying both sides by dx. Step number 4, right? Once we get the y's and the dy together, the x's, the dx together, we're going to integrate both sides. And then 5, we're going to solve for y. And then if we're given an initial condition, step number 6 is we're going to go back and find c. Sometimes it's easier to find c before we solve for y, and it doesn't matter which way you do it. So you can either do 5 and 6 are interchangeable. You can do one or the other first. Okay, so let's go through an actual example. Keep those steps in front of you, and you can follow along. Hopefully they'll make sense as we go through here. All right, so we're going to start out. We want to solve this equation up here. We got x plus 2y primed equals 0. Okay, so the very first thing we're going to do is replace the y prime with the dy dx. So that step's done right here, right? I have x plus 2y dy dx equals 0. Okay, the next step is I want to get the x's on one side with the dx and the y's on the other side with the dy. So I'm going to start out by, I'm going to subtract that x over to the opposite side. So now I have 2y dy dx equals a negative x. Okay, the next thing is I want that dx with the x. So the way I move it over is by timesing both sides by dx. So now I have 2y dy equals a negative x dx. Okay, that's the first 3 steps we're going through there, right? I want all the y's on one side with the dy. I want all the x's on the opposite side with the dx. The next thing we're going to do is step number 4 is to integrate both sides. So let's integrate both sides. When I integrate 2y, I end up with y squared. And on the opposite side, I integrate a negative x. I end up with a negative x squared over 2 plus c. You don't have to put a constant on both sides, right? Because if I put a constant over here I could do this, plus c, I'll call it c1. There's another constant. But then I just subtract that over. And when I do that, I end up just with another constant over on the far side. So when you integrate both sides, you don't have to put a constant on both sides. Just put a constant on one of the sides. Okay, so that's almost my answer. Now, normally we're going to want to solve for y. So if I solve for y, I'm going to take the square root. When I do that, remember, if I take the square root of both sides, I have to put a plus or minus in front of there. So I end up with that. The problem is that's not a function. And so if we're looking for a solution, it actually has 2, but we're actually going to write it separately. So look down below at the next, it says write your solution to example 1 as a pair of possible functions. The reason why they're possible functions, it can't be both the plus and the minus, or it's not a function. So it could either be the square root of negative x squared over 2 plus c, or it could be a negative square root of negative x squared over 2 plus c. So it could be either one of those two. Okay, so again, the reason why we're writing them separately is because both of them can't be the answers. It could be one or the other. We just don't know which one. Okay, let's try another one. So go to example 2. So we want to find an equation of a function which goes through the point 0, negative 3, and whose slope is x times e to the x squared over y. Well, this is kind of tricky because this is not written as a differential equation, but it does tell me that the slope of my function is this. Well, what that means is if the slope equals that, that means dy dx equals that. So dy dx equals x e to the x squared. Okay, now we're going to, or over y, sorry, I almost forgot over the y. Okay, now we're going to separate our variables. So I want the y with the dy and the dx with the x's. So I'm going to times this side by y. So I end up with y dy. I'm going to times that side by dx. Right? So I end up with x e to the x squared dx. So it's really important to get it set up there. You want all the y's on one side with the dy, all the x's on the opposite side with the dx. Okay, our next step is going to be to integrate both sides. Integrate y, that's going to be 1/2 y squared, or y squared over 2, however you want to write that. When I go and integrate the right side, right, I got an exponential there, so I need the derivative of x squared. Well, I've got an x, so I'm going to times by 2. So there's a 2 in there, that's a 2x now, but that means I have to times by 1/2 on the outside. So I end up with 1/2. And then when I integrate e to the x squared, it just stays e to the, right, the 2x goes away. I integrate e to the x squared. It just ends up being e to the x squared still. And don't forget our plus c on there. I'm going to call it c1, and I'll show you here in just a second why. Okay, let's get the y squared by itself. So I'm going to times everything by 2. So I times by 2 over here, times by 2 over here. So over here I end up with y squared equals. Now when I times through by 2, the 2 times 1/2 is just 1, so I end up with just e to the x squared. When I times 2 by that constant, I just get another constant. And so the reason why I put a c1 is I'm just going to put a c2. All that means is that that constant is not the same as that constant. That's it. Okay, when we get to there, let's put that up here. I have y squared equals e to the x squared plus c2. Now it wants a particular solution. In this case, it gives me information. It tells me that my function passes through the point 0, -3. I need to figure out what that constant is. And I normally, on the last problem, we couldn't do that because it did not give us an initial condition. This one gives us one. So I have two choices. So I'm going to erase this over here. So if you don't have it down, you can pause it, double check that. But I'm going to erase it so I have room. So one is I could solve for y first. So here's the first way I could find c. So if I solve for y, I get y equals the square root of e to the x squared plus c2. And it could be a plus or a minus, right? So I took the square root of both sides. Well, square roots never equal a negative. So the only way I'm going to get a -3 back out is if it's a negative. So I had two possibilities. It could be a positive square root of e to the x squared plus c, or it could be a negative square root of e to the x squared plus c. Well, the square root's always positive, so it would have to be a negative square root of e to the x squared plus c in order to get a -3 back out. Okay, now I'm going to plug -3 in for y and 0 in for x. I'm going to plug in that initial condition to find out what we get. So I'm going to go -3 equals a negative square root of e to the 0 plus some constant. E to the 0 is 1, and I could divide by both sides by -1. So I'd get 3 equals the square root of 1 plus c. Square both sides. This side would be 9. That would be 1 plus c now, minus the 1 over. So c is equal to 8. So my particular solution is y equals a negative square root of e to the x squared plus 8. And there's my particular solution. So that's one way to find c. The other way, and I kind of like this way, at least on this problem better, is you can take the 0, -3, and you can plug it into this equation before I solve for c. So if I do that, I'd get -3 squared, which is 9, equals e to the 0 plus c2. Well, e to the 0 is 1. I minus the 1 over. So doesn't that seem a little bit easier? So now I have y squared equals e to the x squared plus 1. And now just solve for y. Now it could be a plus or a minus. So you still have to look up here and say, hey, I get a -3 back out. Well, square roots are always positive, so to get a negative, I'd have to have a negative out in front of it. So I know this is my particular solution. So that's what it means that those steps 5 and 6 are interchangeable. You can either solve for y first, like we did over here, and then find your constant, or you could find your constant first. That's what we did over here, and then solve for y second. And sometimes it just depends on the problem. So I usually look at it, if I get this, and it looks pretty easy to plug 0, -3, and then find my constant, I'd probably do that first. I'll show you an example in a second. Well, maybe I wouldn't do that, where I'd probably use this method over here rather than the second one. But again, you could do either one. It's up to you. Okay, so this says find a general solution to y - 2 equals x dy dx. This one's a little bit tricky. If I add the 2 over first, the problem I'm going to have, so don't do this. I'm just going to show you something. If I add the 2 over now I can't just times by dx because I have this 2 over here. So on this problem, I think what I would do first is I would times by the dx first. So you end up with dx times y - 2 over on this side. And over on this side, I have x dy. And hopefully you're thinking, wait a second, I got the y's with the dx and the x with the dy. We don't want that, which is right. But what I'm going to do to fix that then is I can't divide by dx because it has to be multiplying by dx. So what I'm going to do instead is I'm going to divide by the y - 2. So divide by y - 2 over to this side. And then I'm going to divide by the x over to this side. So what ends up happening is this, is I end up with 1 over x dx, right? The y - 2 goes away. And over here, the x's go away. So I end up with 1 over y - 2 dy. So that can be a little bit tricky. Make sure, again, your goal is all the x's on one side, all the y's on the other side, the dx with the x's, the dy with the y's. Okay, now it's all ready. We can integrate both sides now. So let's integrate both sides. Well, the integral of 1 over x is just the ln of the absolute value of x. I'm going to put my plus c, I think, actually over on that side. I'm going to call it c1. Okay, equals, and over on the other side we get the ln of y - 2 over on that side. Okay, and it says to find the general solution and the particular solution. So let's find the general solution first, and then we'll go back and find the particular solution after. So this is a little bit tricky, so make sure you're focused. I want to get y by itself. I can't get y by itself as long as it's trapped inside of that ln. So I need to get rid of the ln's. So what I can do is I can take both sides and I can rewrite them as being e to that power, e to the ln of the absolute value of x plus c1. And over here I have e to the ln of y - 2, the absolute value of y - 2. The reason why I did that is because this e to the ln just cancels out. Over on this side is a little bit trickier, and you have to be really careful with this. Over here, these two powers, the e and the ln of x don't cancel out because of the plus c1. It has to cancel both of them out, which it doesn't. But I can take those two powers and separate them, right? When we add the powers, it really means I'm multiplying the bases. So that's really the same thing as this. E to the ln of the absolute value of x times by e to the c1. So what I did again is I took e to, right, if I times those together, e to the ln of x times e to the c1, keep the base the same and I add the exponents. I end up with this back again. So you can, just like you can combine two things with the same base, if you have a base and the powers are added together, you can separate them by multiplying. Okay, this is going to get a little tricky now. This part, e to the ln, they just cancel out now. So that would just be, I'm going to move this down even more here so we have room. So we end up with the absolute value of x times by, and then e to the c1, well, e to a constant is just another constant. So I'm going to call it c2, it's just a different constant. And over here I have the absolute value of y - 2. Okay, I'm going to come up over here. So I have the absolute value of y minus 2 equals some constant times the absolute value of x. Well, if you remember, the way we solve an absolute value problem is we just get rid of the absolute values, and I put a plus or minus on one side. Okay, now this is a little bit tricky, but when I get to right here, this number, plus or minus a constant, is just another constant. It could be a positive or negative, but it's still another constant. So my final thing is I can get rid of the plus or minus. Y minus 2 equals, I'm just going to call it C this time. Okay, we're right there. I can add the 2 over, so we end up with y is equal to cx plus 2. That is my general solution. Okay, is y equals cx plus 2. Okay, I still need to figure out what c is equal to, so I come back up. This is a second part, so we're down to part B. Part B says find a particular solution for this. This is the same equation. We got the general solution right here, right? So we already found the general solution. We want to find a particular solution. It tells me when I plug 1 in for y, I get 1/2 back out. Okay, so I'm going to take the 1/2 and plug it back in there. Be careful, that's plug-in, when you plug 1 in for x, excuse me, you get 1/2 back out. So we're going to go 1 is equal to, sorry, 1/2 is equal to my constant times 1 plus 2. I just need to solve that equation. So I'm going to minus the 2 over. C times 1 is just C, minus that 2 over to there. That ends up being a negative 3/2. Okay, that's what my constant is. So my particular solution would be, let's go back up there. And my particular solution would be y is equal to that's it for as far as that's the last example as far as that we're actually going to solve a differential equation. If you do look at this next part though, it says, right, an algebraic equation like x cubed plus x squared plus 4 equals 0 can't be solved. Like we don't have any way of solving that without a calculator. But we could answer this question. So the question is -2 a solution to that equation? So we can check that. Let's plug in -2. Like, does it make the equation work? Does it make it true? So this would be -8 plus 4 plus 4 equals 0. Okay, that's true, right? That does come out to equal 0. So we would say, is it a solution? Yes. Okay, so this next one, it's a little bit different. It says, is y equals 1/2 e to the x plus e to the negative x a solution to the differential equation y primed equals e to the x minus y? By the way, there is no way to separate those variables. We can't separate the e to the x and the y and get the dx with the x and the dy with the y. So the method we've used, we just used to solve this, doesn't work. So we don't have any way of solving it, at least using the methods that we know. But that's not what it's asking. All it's asking is this a solution to this differential equation? Well, to find that out, it has a y prime over there. I need to figure out what y prime is equal to. So let's solve y prime. So y prime equals, just take the derivative. 1/2 e to the x, you take the derivative. It's still 1/2 e to the x. Okay, take the derivative of e to the negative x. Well, the derivative of negative x is a -1, so that drops down. That's my hook-on factor. So there's my derivative right there. Okay, so I want to find out, again, is this a solution to this equation? Well, for y prime, then, I'm going to plug in what y prime is equal to. So let's plug that in. I'm going to go 1/2 e to the x minus 1e to the negative x equals, and now on the right side I have e to the x minus y. Well, in place of y, I'm going to come back up here and put what y is equal to. So that would be 1/2 e to the x plus e to the negative x. Okay, Oh, and also make sure we're subtracting that whole thing, right? So just be careful with that. Okay, so the question is, do they come out to be equal? So let's check that. I'm just going to simplify the right side over here. There's not much we can do on the left side. So if I distribute that through, I get e to the x minus 1/2 e to the x plus e to the negative x. Let's just be a 1/2 there. Hey, those two I can combine together. They're like terms. So that's 1 e to the x minus 1/2 e to the x. So 1 minus 1/2 is 1/2. Or, okay, sorry, I got to carry that minus through over here. Hopefully you guys caught that. That minus needs to carry through to both of them, right? So this should be minus 1/2 e to the x minus e to the negative x. Okay, so we end up with that. What do we have over here on the left side? Hey, they're the same thing. They equal each other, so it checks off. So we'll come back up here. Is y equals this a solution to this? We would put yes, it is a solution. So just to review really quick, if I want to find out if this y is a solution to that y prime, what we're going to do is, first of all, find out what y prime is equal to, and then I'm going to plug it in for y prime right there. But because there's a y on this side, I have to take what y is equal to up there, and I have to plug it in for y right there. And once I do that, I'm just checking, do the two sides come out to be equal? If they do come out to be equal, then you're good. It's a solution. If they don't come out to be equal, then it's not a solution. So that's a way we can check if something is a solution to a differential equation. And that's something they could ask you on the AP test. You're not actually solving the differential equation. That one we can't solve, at least using the methods that we know. Okay, these are a bit tricky, but follow the steps, practice with them. Make sure if you got questions, you're asking me. Thanks. Good luck.